One of the most common complaints that mechanics get about people's cars is it's losing power while accelerating. You're driving along, everything's fine until you put your foot down, and instead of hit a flat spot where the engine dies or there is no increase in power whatsoever. And diagnosing this just requires that we have an understanding of all the factors that are involved that could potentially contribute to an engine losing power while we're accelerating. The quicker we diagnose this fault, the cheaper it will be. In the main, if we ignore faults or allow them to run on, they become more expensive. There's more components that are involved, or the damage becomes much greater. It really is worth listening to our car and what it's trying to tell us when we hit that flat spot when we're trying to accelerate. We're going to break down the 4-stroke cycle and look at how different components within the engine contribute to each of these. You've got the suck, the squish, the bang and the blow. Now let's look at the phases. We'll start off with the suck, the intake phase where air goes into the engine. When we're accelerating, the car needs more air. It's got to match air and fuel to produce power. If we want more power, we logically need more air and more fuel. That really is a critical part of the intake phase of the engine. Now, things to check would include the air filter. If the air filter is clogged, the engine is just not going to be able to breathe in sufficient air. It may be fine at lower RPM levels, but you start to hit the limits as the RPM increases, and a clogged fuel filter is a classic contributing factor to a loss of power when we're accelerating. The air filter should typically be replaced every 15 to 30,000 miles. It probably depends on where we live in the world, what the pollution levels and the dust particle levels are like, but for most drivers that is a good ballpark, and most manufacturers set the replacement at about 30 to 40,000 miles. I would shorten that a little bit just to be on the safe side, particularly if we notice a problem when we're accelerating, and changing an air filter is relatively easy to do. If the engine can't get enough air, the fuel mixture is going to be much greater than it should be, and this is a condition we would refer to as running rich. And when we've plugged in the OBD2 port reader, we're probably going to get error codes. P0172 and P0175 are typical error codes that would point to this situation where the fuel is too rich due to a lack of air going into the engine. But those codes do not confirm a blocked filter. It could be the mass airflow sensor or even a faulty injector producing the same effects, but at least we now know where to start looking. The MAF, the mass airflow sensor, sits between the air filter and the engine. It monitors the amount of air and helps the car determine how much oxygen it's got to play with in order to supply sufficient fuel. If that airflow sensor has degraded, if it's become dirty or soiled, it's going to give the wrong readings and the car is going to mess up the calculations, and that's going to manifest itself under acceleration or under load. The fix is often just using a straightforward MAF cleaning spray or cleaning solution. Make sure it is approved for the airflow sensor. It is possible to damage these by using the incorrect fluids which leave a residue on, effectively blocking it and causing all sorts of measurement problems. Most modern cars have a butterfly valve called the throttle valve or the throttle plate, and it controls the amount of air that can enter the engine. Literally by opening or closing this butterfly will determine how much air is getting into the engine. And in modern cars, it's not mechanically controlled by the accelerator, it is electronically controlled. Now, carbon deposits can build up in this area. The positive crankcase ventilation, the exhaust gas recirculation system can all contribute to clogging up of this butterfly valve, and as it starts getting coked up with carbon, it's not opening or closing as effectively, or the airflow is more restricted through it, and that can lead to problems accelerating and causing these flat spots. It's a really good idea just to dismantle the intake, get to the throttle body itself and clean it off. Remove any carbon or oil residue that has built up just to make sure it's working within its design parameters. Talking about drive-by-wire setups in the modern car, the accelerator pedal is no longer mechanical. It has something to read the accelerator position and to transmit this to the ECU. Now, sometimes these sensors start to fail at certain positions. They develop weak spots or flat areas, and that just sends dodgy information to the ECU, and that can lead to a loss of power when accelerating when the throttle is at these positions where the signal is not as good. And in most modern cars, the ECU will interpret this dodgy signal as a fault and it'll go into limp mode, reducing the power. The repair is relatively simple. It's generally under about £80 to fix that in most cars. Vacuum loss is also a significant thing. The modern engine requires a vacuum particularly if it's not turbocharged. You've got to get the air flowing into the engine, and generally the engine will be under vacuum for a lot of the combustion cycle. Now, if there's a crack in a hose, a split somewhere, a seal is not seated correctly, that can lead to a loss of this vacuum, and that can result in a loss of power. It's just not able to suck in sufficient air in that part of the phase. You'll often get a high-pitched hiss when this happens, and you can hear that under the bonnet. Get someone to accelerate gently, and if you hear this hiss, it could well be a vacuum leak. A smoke test on the intake is the most reliable and easy way to determine the source of this vacuum leak. Next phase, we've got the squish, the compression stroke. Now, what can go wrong on a compression stroke? Well, if the rings have become degraded, the compression is lost in the engine. It's not able to compress the air. Some of that pressure is being lost into the crankcase. It could be a blown head gasket or even scored cylinder walls. They can all lead to this loss of pressure on the intake stroke. When you're under boost, you need all the compression you can get. Running at relatively low RPMs, it doesn't matter too much, and the engine can compensate for any anomalies there, but it will manifest itself the minute we put our foot on the accelerator. A compression test is the easiest way to determine if this is the problem. You just unplug a spark plug, put the compression tester tool in, and just check the compression on each of the cylinders, and they should all be relatively close to each other. But if you have a runaway low compression cylinder, you can bet that that is at least a significant part of the problem. Low compression doesn't always produce a fault code, annoyingly, but you might get codes that relate to persistent misfires from weak compression. If it's not compressed enough air, it's not going to fire correctly, it's not going to burn correctly. Variable valve timer. Your modern engine is able to control the opening and the closing of the valves. The cam does this job, but variable valve driving takes it to the next degree. Depending on whether we're operating under load, the engine is producing a lot of power, or you need the fuel economy, it can trim the opening and closing of the valves accordingly. If there's a malfunction in the variable valve timing system, that can cause this problem on acceleration. The valves are staying open or closed for too long a duration, and that means we're going to be down on power. And again, that's something that's going to manifest itself at higher RPMs, whereas the engine can cope admirably well at lower RPM. Oil condition has quite a major bearing on the VVT, or the variable valve timing systems. They're quite sensitive to wear and tear caused by the wrong grade of oil or insufficient oil pressure. Do check the oil, and a lot of these faults will manifest themselves straight after an oil change, particularly where the wrong grade of oil has been used. If that's the case, changing the oil for the correct spec will usually fix the problem, but if you run too long with it, you're going to have all these knock-on problems to sort out from that because you've ignored it. The timing chain connects the crank at the bottom of the engine with the valve train at the top and ensures that the opening and closing of valves is all synchronized correctly. If that timing chain is stretched or the tensioner is not working correctly, that can lead to anomalies in the valve timing, and that can lead to similar problems that we've just discussed. Check the chains, check the tensioners, check the belt, make sure they're not degraded and you've got sufficient tension in there. And also, if it's just been changed, make sure it's on correctly. If the tooth is misaligned slightly, that can cause these error codes and these problems. The camshaft position sensor tells the ECU where the camshaft is and helps it to make calculations and diagnose where the anomalies are actually occurring. When the sender fails or it gives an intermittent signal, the ECU is going to panic. It's going to throw the car into limp home mode to protect itself. You're going to notice this as a misfire, the engine idling erratically or misfiring under acceleration. This will usually start off as an intermittent fault and it will get progressively worse. The crankshaft position sensor performs a similar function to the camshaft position sensor. It tells the ECU where the crankshaft is, helps it to make calculations as to where the pistons are in the engine, whether they're at top dead center or elsewhere, and significantly contributes to the smooth running of the combustion cycle in the engine. Intermittent signals from this crankshaft position sensor can cause the ECU to make bad calculations in terms of firing the spark or other issues, causing the ECU to run into limp home mode. The bang, this is the combustion stroke. This is where all the fun and the magic happens inside the engine. What can actually affect the combustion stroke of the engine? Poor fueling, weak ignition are the major contributing factors that cause the engine to hesitate, misfire or lose power. The spark plug is that critical component in the engine that fires the spark that ignites this fuel air charge. Obviously not in diesel engines. Your modern iridium and platinum plugs are usually good for 60,000 miles. I remember on older engines we had copper cord spark plugs and these needed to be replaced annually and we needed to clean them quite often. If these plugs have become degraded, that will affect the spark, the power from from the spark. P0301 and P0302 will indicate where the spark is failing. Inspect the plugs one at a time. Just check that they're not worn, that the electrodes are correct, that the gaps are consistent between the electrode and the tip of the spark plug, and we're looking for soot or oil or carbon buildup on the spark plug itself. Ignition coils are what take your 12-volt charge from the battery and step it up to such a point it can jump that air gap in the plug. Modern engines typically have a different coil for each spark plug. If that coil is degraded, the spark is not going to be as strong, it's going to fail, you're going to have a misfire, and again at higher RPM it's going to manifest itself more strongly than at lower RPM. The fuel filter sits between the tank and the engine, effectively screening out contaminants. Now, a lot of modern engines don't have a changeable fuel filter. It's built into the fuel supply system. But if there's a blockage in the fuel supply, particularly through any filter, that is going to mean you're not getting enough fuel at the engine. It's not going to have the correct mix. The stoichiometric ratio is going to be off, and the engine is going to be down on power. It's going to misfire. You're going to lose power when accelerating. If that fuel rail pressure is too low, it could be a number of things within the fuel system. The fuel injectors themselves spray a fine mist of fuel into the engine itself or into the intake, depending on whether it's direct injection or port injection. If these are clogged, that mist is going to be compromised. It's not going to burn as effectively. Direct injections particularly are very vulnerable to carbon buildup on the intake, and this can silt up the fuel injectors, causing all sorts of problems and lots of misfires. The fuel pump and fuel pressure, this is the critical thing. The injectors really are just gates that open and close. They need the fuel pressure behind them in order to work effectively. If the fuel pump is not working correctly, that pressure is going to be too low. You're not going to get sufficient fuel into the engine. You might get adequate pressure at idle, at low RPM, but as soon as you start to increase the throttle, you're going to notice you're hitting flat spots and problems because enough fuel can't be supplied to the engine. Some modern fuel systems operate at 2000 bars of pressure, which is significant. It doesn't take much to degrade that to a level where the engine is going to be down on power or giving you flat spots. Engine knock and detonation, this is where the fuel ignites prematurely in the engine. That can cause you to lose power accelerating. You'll typically notice a pinking or pinging noise. You'll hear this detonation happening inside the engine. Your modern engine has a knock sensor. It's very good at backing things off when it detects this is happening. So if it's happening early, it's going to back off early on the power, and you really are going to feel that as a driver. It'll typically retard the timing. Now, if you knock the timing back by say 10 degrees, you're going to feel that as a driver. It's going to be significantly down on power. Make sure you're using the correct octane of fuel. Some engines are designed for high octane fuels, and if you put the low octane stuff in, they don't perform as well. Sometimes it may just be an old batch. It's been sitting in the fuel station forecourt for a period of time and it started to degrade. When you actually test the fuels that come out, you don't always get the claimed octane rating that is labelled on the pump. The EGR valve, this allows a little bit of exhaust gases into the intake to reduce the nitrogen gas emissions from the engine. If the EGR is stuck open, or it's stuck closed, is going to affect the running of the engine. It could just be caused by carbon building up in the intake through the EGR system or in the mechanism of the EGR itself, causing it to stick. Bad earth connections, you need a good circuit, a good connection to get everything running in the engine. And there are instances where when things get warm, the connections break down with vibrations from accelerating. That can cause a significant break in the connection at certain points or at certain sets of vibrations coming from the road. It can be very hard to track down earth problems, and a lot of the symptoms you get can mimic a lot of these other faults we've discussed. Check the main earth straps from the battery to the earth part of the car chassis. We're looking for corrosion. Sometimes corrosion builds up, causing the contact to weaken. If you can, clean the connections, take the corrosion off and restore them. Oh, this is the exhaust stroke where the hot gases are allowed out of the engine. If there's a blockage in the exhaust, that's going to reduce the effectiveness of getting these gases out of the engine, and if they remain in the engine, that is going to substantially affect the combustion process that's going on. Typically your particulate filters, your catalysts, or even the mufflers can get clogged up over time, particularly if the engine's been producing excessive amounts of soot. Keep an eye on the oxygen sensors. These sit in the exhaust system, typically between the catalysts and other pollution control systems, and they tell the ECU what the state of oxygen is coming out of the engine, allowing it to make decisions on what to do with the combustion. The turbocharger, that can affect the exhaust phase of the engine. The exhaust gases are driven through the turbocharger to spin up the turbine to collect air on the intake side. If the turbo is failing, the bearings are worn, it's not working as efficiently, it's going to create drag within the exhaust stream. Conversely, this can also cause boost leaks where there's a loss of air pressure going into the engine. I hope you found this video useful. Let me know what your experience has been with this situation of losing power while accelerating and what your fix was, and whether this video was particularly useful or got you to think about something that maybe you'd overlooked. I hope you found this video useful. Please boot the like button. I've lined up this video and this playlist that will just help you to get the best long life out of your car to keep on top of all the maintenance. And if you're not subscribed to the channel, please do so. That would really help us to get out there and you won't miss out on the great video content we've got planned. Thanks for watching. See you in these next videos.